Hello everyone, in this video we're going to be talking about scanning particular port ranges, right? So this is where things start becoming interesting, and you know the great thing about Nmap is you can control every aspect of the scan based on the network ranges and the ports that you want to scan for. So when we talk about port ranges, by default, as I said, the default Nmap scans for the 1000 most commonly used ports. The total amount of ports that you can scan for or that are available are 65,535. So you might be wondering, how do we scan for all ports first of all, right? So to do that, we specify Nmap and then we specify the port option. Right now, after we specify the port option, we can now specify the port range. So we can say, for example, if I wanted to scan only port 22, I could say port 22, right? And that is the SSH port, and then I can enter in my target. So we will run that, and I just want to run it for to actually prove a point here. So I'm going to scan my I'm going to scan the Metasploitable 2 box. So 192.168.1.121, that is the IP address of the Metasploitable 2 box. If you want to discover the box on your side, again, you can run your host discovery options or your host discovery scans, and you'll be able to discover it that way. So I'm going to hit enter, and you can now see it only scanned that particular port. So this is very, very cool because you can sort of specialize, or you can fine tune your scans to the particular ports and services you're looking for. And when we'll be talking about the Nmap Scripting Engine, this will become extremely powerful, because when you're using Nmap scripts to perform enumeration, you want to be very specific with the port that you're targeting. So that is how to specify one port. If we're specifying a whole other number of ports, we can then say, port 22, let's see, port 80. So we say port 22, port 80, let's see, what other ports do we want to scan? Port 443, sorry. And we can then specify the target, and this will scan only these ports that we're specifying. So I'll hit enter, and there we are. It tells us that now, this is where the state is important. Port 22 is open and it's running SSH. Port 80 is open, it's running HTTP. Port 443, which runs HTTPS or HTTP over SSL, is closed, right? So again, this is very, very cool because you can scan for particular services, and then Nmap displays the results for you based on those ports, and will give you an accurate port state here, which tells you that if a port is open or closed. So that is how to specify various ports that you are interested in scanning. Now let's talk about port ranges, right? So let's say I want to scan ports maybe 1 to 1000, right? Mind you, these are not the most commonly used ports. This is just port 1 to port 2 to port 1000. So again, I can say port 1 to 1000, and I specify the target device 192.168.1.121. So this is going to start off from port 1 all the way to port 1000. So I'm going to hit enter. This is not a particularly important scan, and as you can see, it gives us all the results that we were looking for. So it scans 1000 ports. Mind you, as I said, this is not your default scan where it scans for the most commonly used ports. So I can actually prove that. So again, if we take a look at the results here, you can see it goes up to 514, right? And it goes through it. It goes through it in an ordered fashion from the number 1 all the way to 1000. If we run our default scan and I say 192.168.1.121 and I hit enter, you'll now see that the results are vastly different. So not only does it scan the ports outside of the range of 1000, it gives us ports all the way to the number 8180, right? So you can see the difference between using the default scan and then specifying your own port range. So that is using a port range, and again, you can specify to whatever range you want or whatever range you're interested in. Now let's go to the initial question, which is how do we scan the entire 65,535 ports, which will take a while. And we can optimize these scans, which is why we're going to be taking a look at the TCP Connect and the SYN or the stealth scans in the next videos. So if I say Nmap and I want to specify all the ports, I use the -p- option, and then I specify the IP or the target or the entire network range if I want to. In this case, it is just the Metasploitable 2 virtual machine, and I hit enter, right? And you can now see it scanned all 65,535 ports, and we can see that right over here. In this case, it only went through the 505 ports because of the 35 or so the other ports that were currently open. So again, it tells us that 65,505 ports were closed. The rest of them are all open. So you can see we have a port open on FTP, SSH, Telnet, SMTP, domain, HTTP, and NetBIOS. We also have a shell. Let's see, we have tons of other services, and so on and so forth. So that allows you to scan the entire range, which is extremely useful because mostly when you're performing black box testing, or when you're performing CTFs, when you're going through a CTF, you want to enumerate as much information as possible, and you want as accurate a picture of your target device as possible. You want to enumerate all the ports that could possibly be open, and that's how to do it. Now, the cool thing with Nmap is you can also perform protocol or service specific scans, which I really don't recommend. I always recommend that you specify the port that you want. However, you can also run protocol or service specific scans by typing in the P option. So then I can say the protocol or service is SSH, and I want you to scan for SSH on the Metasploitable 2 virtual machine, and I hit enter, and there we are. So that works as well. I can also change this to Telnet, right? And can hit enter, and again that gives us the protocol we're looking for. And if I then search for something like HTTP, and again that tells us that we have it on port 80 and port 8008, which is currently closed. So again, you can run your protocol specific scans this way, but I recommend always using the port specifier. So just to summarize what we've taken a look at, you can specify particular ports by listing them out and using the comma to separate them. So again, I can say port 22, port 23, port 25, which is SMTP, and then I specify my target. And if I run this scan, you can see it tells us that they are all open, right? Regardless of the ports that I specified. If I want to specify a port range, I can say, port 1 to maybe, let's see, port 20, which is not going to give us much. So let's say port 50, and I hit enter, and that's only going to display ports from 1 to 50. And in this case, it's FTP, SSH, Telnet, and SMTP, and they're all open. We then took a look at specifying all the ports, right? Which is actually what we did right over here. So it's P minus P or hyphen minus hyphen, and we then specify the entire. We can then specify the entire network or the target device. In this case, it's the Metasploitable 2 virtual machine, and there we are. All the ports are listed, and this actually goes through all 65,535 of them. All right, so that is all that I wanted to cover in this video. In the next video, we'll start taking a look at particular scans that involve the use of TCP header flags, like the SYN scan. We also have the TCP ACK scan, and so on and so forth. So that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, and in this video we're going to be taking a look at the TCP Connect scan, or the full open scan. Now, the full open scan is something that again is very, very, very simple to understand. All that's happening in the background is that what Nmap is going to do is it's going to establish a three-way handshake, and it will complete the three-way handshake, and it's only through that exchange, or through this process of the three-way handshake, that Nmap comes to the conclusion as to whether a port is open or closed. So again, what Nmap does is it will send a SYN SYN packet, right? And then based on the response, if the port is open, it's going to respond with a SYN ACK. If it doesn't, if it sends an RST, that means the port is closed. So the story ends there. However, if the port is open, so what's going to happen, as I said, is you send a SYN packet. If the port's open, it's going to respond with a SYN ACK, and then you or Nmap is going to send an ACK back, and it's going to then also send an RST to end the connection there. So all it's looking for is the response, but it also acknowledges and completes the three-way handshake. And again, the important thing about this scan is, number one, it's extremely slow when compared to other scans, and of course there's multiple ways you can improve the performance and the speed of a scan, but we'll be taking a look at that towards the end of this module. And given that it's slow, this is primarily because it's completing the entire three-way handshake. Again, you're not performing anything you're not using any other TCP header flags. This scan does not require any super user privileges, so it's very easy to execute and is also very accurate. However, the only downfall is that it's extremely slow. Running it is very, very simple. All you need to do is specify or use Nmap, and we then say ST, so that we're now specifying the scan. So the lowercase s stands for scan, and then T is the type, which in this case is the TCP connect scan. So what we're going to do now is just specify our target, or we can specify a range of ports if we want. So we can specify the entire range of ports. So we can do that as well. And so all 65,535. So this is quite a comprehensive scan. And then we specify Nmap right over here. You can specify the IP address of the Metasploitable 2 virtual machine, which is 192.168.1.121. And I'm also going to open up Wireshark just to prove to you that it is completing the three-way handshake. And we'll go into our terminal, and I'll just start the capture before that. And there we are. We'll just start the entire scan. And there we are, we get the results quite quickly. And this is primarily because the device, or the Metasploitable 2 virtual machine, is running on my local network, right? So the scans are returned extremely quickly. So we have all the results here, quite a few packets. And we want to scroll all the way to the bottom. So first of all, we have a few ARPs, but then we start sending our SYN packets right over here. So we're sending them to all the ports. And then based on the responses, we can see port 143 is sending an RST, which means it's closed. Port 8888, yes, is closed as well. Our first SYNAC is port 135. It is port 21. We then get an acknowledgement, which we send back to port 21, and we then send an RST right over here. If we just scroll right down, I'm looking for the RST that's being sent to actually terminate the connection. So this is the one being sent here. So RST, that is being sent to port 21, and we have closed that TCP three-way handshake for port 21. So just to recap, if I can just go over it, our initial SYN packet that we sent to port 21 was right here, right? We then get a SYNAC back from the Metasploitable 2 virtual machine from port 21. We can see it right over here. We then send our ACK back immediately, and then we reset the connection over here. There we are. So again, that's the entire three-way handshake, and we're able to establish that that port is open. And indeed, if we go and take a look at the results, port 21 is open. So Nmap does that for all the ports. And as I've told you, if the port is closed, it just simply responds with an RST and an ACK, and that tells Nmap that is closed. And you can go through all the results and take a look at all the ACKs being sent back. And again, that tells us 139. We send an ACK back, and we then reset it. We can find the packet here. So again, you can analyze all the traffic. The scan is a fairly simple scan to understand. We're essentially just completing the three-way handshake, and that gives us more reliability because the responses are again more predictable, and Nmap can come to a solid conclusion regarding the whether a port is open or not, what service is running, so on and so forth. All right, so that is the TCP Connect scan. In the next video, we'll be talking about the much more interesting and stealthier scan, the SYN scan or the stealth scan. Hello everyone, and welcome back. In this video, we're going to be talking about the stealth scan or the SYN scan. Now, the SYN scan is interesting as well because it essentially implements or uses the TCP three-way handshake. However, it does not complete the connection, it cuts it in half, right? So all Nmap is doing is sending a SYN packet, and then once it gets the SYNAC back, it then resets the connection instead of acknowledging it. So it does not actually complete the TCP three-way handshake. Now, you might be wondering, well, why is this so important, or why is this a scan option at all? Well, first of all, because it's essentially halving the process or the TCP three-way handshake. It's much faster and it's much more efficient. And because of the fact that you're not completing the three-way handshake, it's used multiple times to bypass firewalls. And again, it can be used to also mask or to be masked as normal traffic. Now, we will touch upon this when we start talking about firewalls. But for now, just take those 2 points. Number one, it's much faster than using a standard TCP Connect scan. And number two, it's much more of a stealthy scan. All right. So first of all, Running it is extremely simple. We need to just specify the Nmap option here, so Nmap SS, and that is how you specify the SYN or the stealth scan. And then again, we can specify the entire port range, and we then specify the IP of the target device, which in this case is Metasploitable 2. And I will also open up Nmap just to display the results for you. So we'll open up Nmap and we'll run the scan here, and I'll just take you through the results. So the scan is complete, and we have our results here. And again, just going through what's happening here. First of all, Nmap sends a SYN packet, and then the target, if the port is open, will respond with a SYN ACK. If it's not open, it will respond with an RST, and then the response based on what Nmap gets will be an RST immediately. So it does not acknowledge and then reset, it just sends the reset packet. All right, so let's take an example of port 21 or port 22. So let's look for the SYN request being sent for port 22. We can see it right here. Nmap is sending the SYN request to the target for port 22. We can see we get on our RST packets, or our RST ACK packets, sorry, back from the target for the ports that are closed. However, we get a SYN ACK back from port 22 right over here. We sent our initial SYN, we get a SYN ACK that tells Nmap that the port is closed, and immediately Nmap will send the RST packet to essentially close the connection. So it does not complete the TCP three-way handshake. So this is a much more stealthier scan because you're not completing the three-way handshake. And more than that, it's much faster than running your TCP connect scan, which again needs to complete it and send more packets. So it's also much more efficient scan. So again, you can run this on you can run this scan on any target, and as I said, it's extremely efficient and is used quite a bit. We'll talk about why exactly it's stealthy, because right now there is no context as to how these scans interact with the firewall. I intend to cover that on its own module. So this is just your SYN scan, or your stealth scan, as it's commonly known as. So again, as I said, you can run it in conjunction with any of the other scan options. When we start taking a look at operating system detection and service version detection, all of these scans will come together to give you a very comprehensive scan on your target. So again, that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, welcome back. In this video, we're going to be taking a look at operating system detection and service version detection with Nmap. Arguably, two of the most important scans that you can run on your target. So just to recap what we've taken a look at so far, and just to put into context why we're taking a look at operating system detection and service version detection, we've taken a look at host discovery. So we now know how to map out our entire network and how to discover devices on our network through various types of scans. We also have learned about port ranges and port specific scans, and how to perform the TCP connect scan and the stealth scan to get reliable results, and to improve the stealth and the speed of our scans, our port scans in particular. So we've identified that information from our target. Now, what other piece of important information do we need to gather from our target? Well, now we need to start understanding what our target is running. So what operating system is it running? Secondly, we need to understand, or to know what service versions are running, for the services that are currently running on the open ports on our target. So in our previous video, when we took a look at the stealth scan, as I already mentioned, we were able to enumerate we were able to perform the entire scan on all the ports, and I mentioned that we can combine Nmap options and scans together to fine-tune our results, and that's exactly what we're going to start doing now. So let's say I want to detect the operating system, or perform operating system detection on our Metasploitable 2 virtual machine. I'll type in Nmap, and I can now run a stealth scan, right? So I want to ensure that this is a stealth scan, and this will give us a faster scan altogether. And then I want to specify the capital O option, so -O, and that means operating system detection. And then I can type in my target or my entire network range or subnet. But in my case, I'm going to be targeting the Metasploitable 2 virtual machine. So I'm going to hit enter, right? And that is going to perform the simple stealth scan, and it's going to scan for 1,000 ports. That's because we did not specify any ports. And then again, operating system detection, and then we specify the IP address there, and so it gives us the information we were expecting. So we have all the services, so the port, state, and service. And if we scroll right at the bottom, you can now see we have operating system detection. So again, it tells us it's running Linux version 2.6 kernel. So again, it gives us the operating system details. So again, it gives us the information that we're looking for. That is Linux 2.6.9 or 2.6.33. So the thing about Nmap operating system detection is it will do it in terms of the probability. So it'll give you a probability rating. Now with Linux, it'll typically give you the types of kernels that this machine is expected to be running. If I fire up the Metasploitable 3 virtual machine here, which I'll do shortly, let me just start that up, and we can also perform the operating system detection and service version detection scans on it. So what I'm going to do is I'll go back into Kali and let's take a look at service version detection. And this time we'll perform it on all 65,535 ports, right? So again, we type in Nmap, and I can also run this as a stealth scan. So I say SV, so that is the SV minus SV, so that is a lowercase s and an uppercase V, stands for service version detection. And we're also performing an operating system detection, and we're running this on all ports. So you can see we are combining our scan types, right? So again, we're specifying a stealth scan, service version detection, operating system detection on all ports, and then we specify our IP address, which is let's start off with the Metasploitable 2 virtual machine, and I'm going to hit enter, and we want to give that a few seconds to run. And while that's running, we can start up our Metasploitable 3 virtual machine here. So let me just get that started. Keyboard Control Alt Delete, and we'll log in right over here. And currently the firewall is disabled, so we'll leave it as it is. And now that that's running, we can wait for this scan to complete. So that is going to take quite a while, because when we run the service version detection, now it's going to try and attempt to detect the various service versions that are running for all the open ports. And you'll see how that looks like once the scan is complete. So I'm just going to wait for this scan to complete. All right, so the scan is completed, and as you can see, it took about 131 seconds. And we now have a lot more information that's useful for you if you're a penetration tester, and I'll demonstrate that shortly. So again, let's just take a look at the summary here. So we have it gives us a summary of the ports that was scanned, and it tells us that 65,505 ports are closed, and then it gives us all the information we know regarding the port. So again, the port, the state of the port, the service that's running. But now we have the service version, which is right here, and that tells us the version of the service that is running. So if it's FTP, it gives us the version of FTP that's running. So that tells us it's running VS FTPD 2.3.4. For SSH, it's running OpenSSH 4.7 P1, and again, this is running Debian on Ubuntu, which will also give you more information regarding the operating system that's running. That's the other cool thing with service version detection, is it can also give you an idea as to what operating system is running if the operating system detection is not clear enough. So again, if we take a look at the result here, for the dist ccd service, you can see it tells us that it's running Ubuntu 4 version 4.2.4.1. Of course, we can't go off this immediately and say that that's completely accurate. But again, it gives you a hint as to what's running. In this case, we have I'm pretty sure that it's running Ubuntu, given that we have various Ubuntu banners being picked up here. So you can see we have tons of services running, and now that we have the service versions running, we can now, as a penetration tester, perform vulnerability analysis. And just a basic example of this is, for example, targeting the FTP port, right? So if I find that an FTP port is running, the first thing I'll do is, of course, I'll try and perform an anonymous login. So I say 192.168.1.121, and I just say, hey, I want to log in as an anonymous user, and I just hit enter, and you can see it's successful. So that tells me, okay, so anonymous login is allowed. This will become more apparent when you start using Nmap scripts for enumeration. That will actually tell us that FTP has anonymous login allowed. So I have access to FTP here. However, I can also perform more vulnerability analysis. So if I just scroll through the results here, I can see that the service version is VS FTPD 2.3.4. I can then use a tool like search exploit. So I can say search exploit VS FTPD 2.3.4, right? And I can run that, and that'll tell me, hey, there's an exploit for this service. So it tells us there's a backdoor command execution exploit under Metasploit, and then I can exploit it. So you can see how important service version numbers are. All right, so this is the service version detection and operating system detection for the Metasploitable 2 virtual machine. Let's try and run it for our Metasploitable 3 virtual machine. So we're going to start from scratch. We're going to perform our we're going to perform host discovery manually, because I don't know the actual IP for the Metasploitable 3 virtual machine. So again, let me just clear my terminal here, and we'll just say nmap, and we'll just run a complete ping sweep on the network. So 192.168.1.1/24, and I want to exclude the Metasploitable IP, so 192.168.1.1.21. Of course, this will differ depending on your network, but again, you can just follow along. So I'm going to hit enter, and let's see what devices we get. Of course, we have our router, the ASRock Corporation, and we can see that the IP address for the Metasploitable 3 Windows box is 192.168.1.38. In this game, we do get a MAC address, and it tells us this is running in VirtualBox. So now that we have the IP, so now we are combining all that we've learned so far. So now that we have the IP, we can perform, we say a stealth scan, and we want to detect service versions, the operating system, and want to scan all ports. So we know it's 192.168.1.38, right? So we want to run that, and we can hit enter, and we'll let that scan run. So I'm just going to let this run, and I'll get back to you when this is done. All right, so the scan is complete, and immediately when we take a look at the scan results, now for a Windows box, and more specifically Windows Server 2008 R2, we can start seeing a lot more information being displayed. So let's go right back to the top here, and again we get the same summary. We get 65,502 ports are closed. And we then get the various columns that display the port, the state, the service, and then the service version. All right, so we can now get tons of information from this device just by performing operating system and service version detection. So let's start off with operating system detection, and if we just go right at the bottom here, we get the MAC address, right, and then we have the operating system detection. So it tells us it's either running Microsoft Windows 7, 2008, or 8.1, right? So this is just a basic prediction based on the probes that were sent and the responses sent back. Now we take a look at the OS CPE. So it tells us this Microsoft Windows 7. It's telling Microsoft Windows 7 7.1. It also gets Microsoft Windows Server 2008 SP1. R2 as well, and the reason all of these three are coming to are coming back, or the reason why Nmap is coming with all of these three operating systems is because they have quite a similar architecture and are built on the same kernel almost, although there are a few changes. So Microsoft Windows 7, 2008, 8.1 are very, very similar that way. Right. So by default, you can see that the service info, based on the service info, you're able to tell that this is running Windows Server 2008 R2 or 2012. Right. So Nmap comes extremely close to what's running, and as we already know, Nmap the Metasploitable 3 box is running Windows Server 2008 R2. So if we take a look at some of these services, we can obviously tell that we have Microsoft FTPD. OpenSSH 7.1, so we can start looking for vulnerabilities for all of these services and trying to find an access vector. We also have the Microsoft Windows Server 2008 R2 Microsoft DS. So again, that tells us from the services we can also start getting an idea of what operating system is running, right? As for the web server, we can see it's running Microsoft IIS HTTPD 7.5. So again, you can then start performing your vulnerability analysis that way. Hello everyone, welcome back. In this video, we're going to be taking a look at the aggressive scan. All right, so the aggressive scan is a very interesting scan. It's a very noisy scan, but most of all, it's one that is very important and very useful for various reasons. But one of them is that it combines 3 different types of scans that usually give a lot of information. 2 of them you've already taken a look at, and that is operating system detection and service version detection. So it combines operating system and service version detection. However, it adds one more type of scan on top of that, and that is your script scan, all right, or your script scanning, which is denoted by SC, right? And we haven't touched up on scripts yet, and there's a good reason for that. I want to give that its own module because, you know, scripts are really, really important to Nmap and to getting more information from your target. So for now, just understand or take or look at scripts as just added pieces of functionality that allow you to get more information from particular services from your target. All right. So for example, if we have an FTP port running, we also have an FTP script that we can run with Nmap that will actually give us more information regarding the version of FTP that's running, whether anonymous logins are allowed, so on and so forth. And I can actually demonstrate because the aggressive scan performs script scanning by default. We will be able to get a whole lot more information than we've been able to get so far. The thing to keep in mind here is that the aggressive scan is an extremely noisy scan in that it sends tons of requests to the particular target. So that's something you want to be aware of. So what we're going to do now is we're just going to run a scan on Metasploitable 2 here. So again, we'll run a stealth scan, and to specify the aggressive scan, that is a minus or a hyphen uppercase A, and then we specify our target. In my case, it's 192.168.1.121, right? And I can just hit enter, and we're going to let that run the scan. So now remember, the aggressive scan is combining service detection, operating system detection, and it's also performing your default script scanning. So I'm just going to let this run, and once it's complete, I'll get back to you then. All right, so the scan is complete, and you can immediately see that we now have a ton of new information that is extremely useful. And that's the real power of Nmap scripts. And in this case, we haven't even run specific scripts. We've just run default scripts based on the services that Nmap is able to enumerate so far. So you can see tons of more information now, and I'll get to what the additional information is. So now that we've run the aggressive scan, Nmap has combined those 3 scans together, and it gives us all of these important bits of information. So for example, we start off with port 21, which we know is FTP. We know the port is open, and the service version is VS-FTPD 2.3.4. We can now see the Nmap script comes after this, right? And it's indented. So this is actually telling you that this right here, this information right here belongs to the port 21. So the Nmap script, the Nmap FTP script, which again, the names are listed out here. So this is the FTP anon script. Will actually tell you if anonymous FTP login is allowed, and indeed in this case it tells us it is allowed. It then runs the FTP syst script, and again that gives us any statistics. So again it tells us not statistics but the status. So it says it actually connects to the it gives you the status. So again, you can go through that information. It gives us the banner here, then end of the status, and you can see just with these 2 Nmap FTP scripts, we're able to get information like whether or not anonymous FTP login is allowed without manually testing it, and we get the FTP server status right over here, the type of input that's allowed. So in ASCII, and session timeout is 300 seconds, which is very important when you're working with FTP. So again, very, very important. As for SSH, you can see it runs the SSH host key script, which again just gives you the host key information here, which is really not that important right now. We then have port 25, which again is SMTP, and the SMTP script that is run is called SMTP commands, and it gives you the various SMTP commands that you can use. We haven't talked about SMTP enumeration yet, so don't worry about that. It also gives us the SSL version 2 ciphers. Let me look for an interesting service. Right, so we have port 80, which we know is running a web server. The web server that is being run is Apache HTTPD 2.2.8, and you know it's running on Ubuntu. If we take a look at the Nmap scripts that were run, you can see we have the HTTP server header Nmap script, which tells us, it gives us the server header, right, which is very important. So it tells us it's running Apache on Ubuntu. For the HTTP title, it gives us the actual title of the website, which is again going to be Metasploitable 2 Linux, and we can confirm this by opening up the IP of the Metasploitable 2 virtual machine. So 191.68.1.121. I hit enter, and if we take a look at the title, you can see it's Metasploitable 2 Linux, and we can see that the Nmap script was accurate and correct there. All right, so what you'll also see is that Nmap is not going to run default scripts for all services, and that's where I'll be covering Nmap scripts in depth and the Nmap Scripting Engine in the Nmap module. In the Nmap scripts module, because it really does deserve its own. And we then have, for example, MySQL here, which is very important. We have some various MySQL scripts that will run. So MySQL info gives you the version of MySQL that's running. The capabilities, flags, we also have the so the default script just gives us the version that's running there. If we take a look at the PostgreSQL database, it gives us the SSL date, which is really not that important. We then have VNC, so again it gives us the protocol version, the security types, and the type of VNC authentication. As for the X11 service, it tells us access denied there, IRC, so on and so forth. So I can go on and keep on rambling about the importance of Nmap scripts and the additional information that you can get. And all of this is combined in one script, in one scan type, and that is the aggressive scan type, which you can specify by using the -A option here. So that, as you can tell, is very, very important. If you want to access the Nmap scripts, I'm just going to tell you where you can find them right now. They are found under the user share Nmap, under Nmaps, under scripts. And if we list all of that, it displays all of the Nmap scripts right over here, and you can actually view them, and you can specify your own script based on the services. You can also see we have various vulnerability checker Nmap scripts that allow you to test a particular target for a particular vulnerability, through the CVE. And again, I don't want to cover this right now because it'll have its own module where we'll cover enumeration and we'll test various vulnerabilities, so on and so forth. So that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at UDP scanning with Nmap. Alright, so we've talked about TCP and UDP in the networking fundamentals module, and we really haven't touched upon UDP scanning. That's because very rarely do you find many services running on UDP ports. However, it's still important. I'm not downplaying it, and performing UDP scans is also extremely simple. So when you're performing a UDP scan, you need to remember that this is not operating like TCP. This is not a connection. This is a connectionless protocol, right? So there's no three-way handshake, and the way UDP communicates is very different. So again, that implies that Nmap will also, determine the responses. It will also send and determine the responses very differently, as opposed to a three-way handshake where you have SYN packets and SYN ACKs determine that the port is open, and RSTs determine that the port is closed. With UDP, what's happening is you're going to send what you're going to do is you're going to send a UDP packet, right? So if the port is closed, then you will get an ICMP echo unreachable or ICMP port unreachable message. Not an ICMP echo, but an ICMP port unreachable message or response. If the port is open, then you'll not receive a response at all. So again, it's fairly simple to understand. So I'll actually demonstrate this through Wireshark. So again, performing a UDP scan is very simple. We simply say SU, so we're saying the scan type, and the scan type is of UDP. Right, and then we can specify the port range, because UDP scans usually take quite a while. I recommend that you specify the port, the actual port range that you're interested in. In my case, I'm just going to scan it from port 1 to maybe 1000, right? Just to keep things standardized, and then I can specify my Windows. I'll actually use my Metasploitable 2 virtual machine, which runs Linux. And then I'll open up Wireshark, right? So we'll open up Wireshark, and we'll start the traffic capture. And immediately, if we go right at the top, we can see we're sending all the UDP packets here. And if we go to the user datagram protocol right over here, so we're sending it. And we're now going to wait for our responses. If we don't get a response, it means that the port is open. And if we do get a response, it's going to be in the form of an ICMP port unreachable response, and we do get them for various ports here. So if you look at the ICMP here, I don't think we'll yeah, we have the source and destination port is 280. Let's click on this one, 929 for, so you get the idea. We have various responses, ICMP responses here. We also get a few more down here, and Nmap essentially just keeps sending UDP packets, and then based on the response, if there's no response, that means that that port is open. If we do get the ICMP port unreachable response, it means that that port is closed. So again, very simple to understand. Nmap is still completing the scan. So what I'm going to do is I'm just going to wait for the scan to complete, and then once it's done, we can start analyzing the results. All right, the scan is complete, and we can take a look at these services here. So in this case, we can now see the occurrence of the open filtered state for various ports here, which again tells us that Nmap is that the requests are being sent, but based on the responses, Nmap is not able to deduce as to whether the port is open or there is some sort of filtering, right? So we have various ports open. If we take a look at the results here, again, as I said, we're sending the ICMP, we're sending UDP packets, and then if the port is open, we don't get a response back. But if we get an ICMP port unreachable response, that means that the port is closed. So again, scanning UDP ports is a fairly simple process, and understanding how it works again is fairly simple. You can also combine various other options with the UDP scan. You can also include operating system detection as well as service version detection in your scans along with UDP. So that is going to be it for this video, and I'll be seeing you in the next video. Hello everyone, welcome to this video. In this video, I'm going to be talking about the reason option with Nmap. Now, the reason option is not a particular scan type or a particular port scan or any scan technique for that matter. It's simply a option or utility that comes with Nmap and is used particularly for diagnostic reasons, and it allows users to know how and why Nmap came to a particular conclusion. So for example, if you send a SYN packet to a target, initiating the TCP through a connection, and they send a SYNAC back, again, Nmap will come to a conclusion that that port is open, right? So using the reason option allows you to view how Nmap came to its conclusions, or how Nmap made a particular decision. And again, you can access this by using the Nmap manual pages. So if I just grep, I pipe and grep the output, and I'm looking for the reason option here, and I just hit enter. So you can see the reason option displays the reason a port is in a particular state. And again, the reason option here, so host and port state reason, so shows the reason each port is set to a specific state and the reason each host is up or down. This again, the administrator running Nmap could cancel it for any other reason as well, etc., etc. Right. So again, the best way to demonstrate this is to actually show you a few example scans with the reason option enabled. So again, we can run a simple ping sweep right on our network here. 192.168.1.1 /24, right? And I can then hit reason. And what I'm saying here is I want Nmap to tell me how it's coming to how it's making its decisions regarding what hosts are online and what hosts are offline. So if I hit enter, right, and this is a simple ping sweep. So you can see that it gives us all the devices that are currently online. And the reason is right over here. So it tells us the host is up, and the reason it's able to determine that this host is up is because it received an ARP response. So as I mentioned, this will use the address resolution protocol again to map IP addresses to particular MAC addresses. So again, it gives us the reason that this device is up again because it received an ARP response. So this is very helpful when diagnosing why you're getting particular results, and it's great even for students who want to know how particular scans work, right? And why and how Nmap is coming to various conclusions and making decisions based on the responses that it's getting. All right, so we can run this for a more complex scan. So let's say we want to run a stealth scan, and we also run an aggressive scan, but we want to run it on port. Let's see, we'll run it from port 1 to 100, and we'll run it on our Metasploitable 3 virtual machine, which is running Windows 0.1.38. And we'll just say reason, like so. And let's see what we get from this particular scan. So again, this is an aggressive scan, so this scan will take a few seconds up to a few minutes based on the amount of ports you specify. And there we are, we get the results, and we can start taking a look at the results here. So you can see based on the discovery, so it tells us host is up, it received an ARP response. And then right over here, if we take a look at let's see, the reason. So we have an additional column, the reason. So it tells us the reason this port is open, or it came to the conclusion that this port is open, is because it received a SYN-ACK back, right? So that's very important. And again, it does this it gives us the reason as being the same for all other ports that are open. So it tells us port 80 is open because we sent a SYN packet and we received a SYN-ACK response back. So again, a very, very great utility for actually understanding how Nmap is, coming to its conclusions or reaching specific decisions. So you can use this whenever you want clarification regarding what Nmap is doing and how the responses are being how they're being enumerated. So again, you can run this with any scan, and it's a great utility or option that you can run with Nmap whenever you want to learn more about a particular scan and why Nmap is coming to particular conclusions or making decisions. And it's also great for students to understand how these scans are being conducted. So you can use this in association with a tool like Wireshark for traffic capture and analysis, right? So that's basically what I wanted to cover in this video. So I'm going to be seeing you in the next video.